Thanks for coming. Let's see. I'm going to try and make this interactive. So I just got back from ApacheCon in Austin. So this is a little bit of augmentation of the talk I gave at ApacheCon on Tika, which is a little bit of an intro to Tika, a little bit some examples of like how to use it and how we're using it for some advanced stuff in image, video, parsing and analysis. The extension to other types of documents and stuff is there. So I'll talk about that, how you can do like machine translation, have a little bit at the end on that, and lots of pointers and hopefully demos along the way. And hopefully this is a meetup, so it's interactive, you know. We don't have like a dunk tank to dunk me in like beer or something like that, but I don't know. Like I can't do that at JPL, but you know, we can do it here. Right, Felix? Okay, yes. So anyways, I just thought I'd try that. Okay, so yeah, so if anyone has any questions, just stop me really, and I'll try and answer it. Like I said, I just want this to be sort of interactive. So okay, a little bit about myself. I had 3 hats. Okay, so here's my introduction. So here's why maybe you care to listen to me, or you know whatever. It's like Felix is a Hadoop engineer here, right? So I was one of the people who created Hadoop, along with Doug Cutting and Mike Caffarella and the rest of the people that were working on Nutch. So one of the hats that I wear is I'm at the Apache Software Foundation. I'm on the board of directors there. And so in 2005, when I was getting my PhD at USC in computer science and things like that, I stumbled upon a project called Nutch, which is web search engine technology that still exists today, largely because it's an Apache project. And Apache is a home for communities and software things to go on and to continue to exist, independent of funding and people and things like that. And so, I worked on Nutch. I worked on a lot of things at Apache. I was also working at JPL at the time because I had to pay the bills, and being a PhD student didn't pay the bills, and Apache doesn't pay me anything, and things like that. And I was also just really interested in NASA stuff and those types of things. I've always been sort of a space cadet. So I'm a chief architect in a number of the people's sections who's actually here today and visiting us too from JPL. Basically what that means is that I've built about I've been like the architect for 3 of our primarily just recently shipped ground data systems that we have. OCO2, which is Orbiting Carbon Observatory, OCO1, ACOS are largely using a system that I helped design. I was one of the principal designers of. Something called SMAP, Soil Moisture Active Passive Mission, the NPOS Preparatory Project, which is National Polar Orbiting Satellite, and things like that are all running the ground data systems largely built on the technologies and capacities that I sort of helped to think about and was part of the team that developed, which had a lot of influence from those Apache technologies like Nutch and eventually what became Hadoop and things like that, and also eventually what became Tika. Okay, so I'll talk about this too, but Tika is a project that was spun out of Nutch by myself and a guy named Jérôme Charon, who was a Frenchman who was one of the Nutch committers at the time. And what we decided, Nutch was a large-scale hypertextual web search engine. It was the implementation of Sergey Brin and Lawrence Page's PhD research at Stanford, which eventually became Google, right? So the goal with Nutch was to make an open environment, make an open web crawler and something that wasn't proprietary that people could test and use and things like that. So it has a crawler, an indexer, content detection and analysis, a query system and things like that. And so what happened with Nutch is that around the time that, like around 2005 actually when I came on in 2006, Doug and a lot of others were taking Nutch and they were deploying it at the Oregon State Open Source Lab, the OCO Open Source Lab. They were deploying it to the Internet Archive. If you've ever used the Wayback Machine, you've used Nutch and things like that. And they were doing that, and what we found is that it didn't scale, which is when Doug was also reading at the time the Google papers. Like it wouldn't scale beyond 100 million websites. And basically, the reason for that was there was large amount of like inter-process communication and things like that. And eventually what happened is that rather than try and fix it ourselves, Doug and others read the MapReduce paper and the Google File System paper. And they implemented a capacity, a technology, and a branch in Nutch that eventually became Hadoop, was Nutch on top of MapReduce and what was Nutch Distributed File System at the time. Well, at the same time, me and Jerome and some other people were like, okay, Hadoop's spinning out into its own project. We're really interested in the content detection and analysis portions of a search engine. Identify a file type, figure out what type it is, parse its text and metadata for the purposes at that time of getting it into a search index and things like that. And so that's some of the early history and origins of Tika. I'll talk more about that later. I'm also a professor at USC. I teach classes in search engines and information retrieval and in software architecture and design. It's synergistic. I use it to recruit students. I help sort of bake off projects and things like that. And because this technology is all open source, we can give them our problems that we have at like NASA and other places, have them solve them using the technologies, and it's a good way to tell whether or not these are a good fit sort of on all sides. So I'm going to start out by talking to you about some of the background with Tika, and eventually I'm going to get into some of the new things that we're doing with Tika, which is really focusing now on images and video and things like that. Tika supports pretty much all of the document types that exist and things like that in terms of getting text and metadata and other things out of it. So basically I'm going to walk you through sort of the history of content extraction, the history of Tika, why this is important, then we'll get into some of the nuts and bolts. So here's some background on Apache Tika, okay? So the idea is that the web is sort of like changing and growing all the time, right? So new sites are being added all the time. And this isn't necessarily indicative of the web. This is just true nowadays, period, right? Whatever content domain, if you're doing ads, if you're doing science, if you're doing business, if you're doing medical, this is basically happening. Large amounts of volume and content are coming. The other thing is that it's not web pages anymore. So in the web and searching the web, it was HTML and things that we were concerned with and things like that. So now, just the content and the veracity of the types of content that are grown, it's way more than HTML. It's PowerPoint files, PDF, images, code. There's a proliferation of content types. So by some accounts, there's between 16,000 to 51,000 different types of content that are out there in terms of file types. And so this is really a coarse-grained estimate. This is provided by a site called fileext.com. What they do is they mine weblogs, basically. And they look at the end of the URLs of the weblog and they say, oh, it's a .cris file. It must be a new type. Oh, it's a .mozi file. This is another type. They may both be text files or whatever, but it's just assuming, like, based on the file extension, this is a new type. A better estimate is actually provided by something called the Internet Assigned Numbers Authority. How many of you are familiar with IANA or DNS, right? So that's an organization that basically are the people behind standards such as DNS and sort of, which is the domain name system, which is the way that we take IPs and we resolve them, we take host names and we resolve them to IPs to get to places on the internet. So IANA also, one of the lesser known standards that they made was something called a taxonomy or a hierarchy of MIME types, which tells us there's about 1,200 richly curated file types that are out there on the internet. These are types that we know their parent and their subtype. We know how to detect them. How many of you knew that files have digital file signatures, like you have fingerprints and things like that?
So
yeah.
it's a magic number?
Yeah, so it's a magic number, right? So Lan brought that up. So we call these magic bytes or magic MIME magic or multimedia internet message exchange MIME magic, which are digital fingerprints effectively for files. And so the IANA registry tells us all PDF7 files start at offset 0 with the bytes bang PDF7, okay? And it tells us that if we see certain byte order markers in files, it must be this type of character set, Latin, US Latin, or UTF-8 or UTF-16, which tells us a lot about where the file came from and things like that, whether it was made in a US country, it was made over here in the US, or if it was made in another country, or things like that. Most of the rest of the world uses things like UTF-8 and UTF-16. We use, of course, in the US something different, US Latin 1 and other types of character sets. So these types of informations are specified in that IANA MIME registry that barely anyone in here raised their hand and know about. And that's totally indicative of most people. They don't know about the fact that files have digital file signatures. So the reason that we want to have and exploit these signatures and know things about them is that we want to do stuff with the data that's in the files. And in a search engine where a lot of this stuff sort of originated from, we want to do things like extract the text, extract the metadata, understand what language the underlying content is, because that influences the way we do that. But in other applications, you want to do different things. Identifying the file type allows you to place it in a particular directory, or to hand it off to somebody. Or in a browser, for example, identifying the file type allows you to direct an action to do with the file. Like when you click on files on the internet and your browser just knows, like, it's a movie file, I should open it in QuickTime. Or it's a image file, I should display it in a particular way. Have you ever wondered, how many of you know that there's a content type or a MIME type mapping in Firefox or in Chrome? Yeah, good. So a few of you have looked at that. Well, it's important because you need to know what the content type is in order to target what the action is to do that. So being able to just detect the file type is extremely useful. Other importance of content types, this is more the search engine use case. This is sort of a canonical architecture for search engines. It basically says like a search engine has a protocol framework to download URLs and across FTP or HTTP or various things. It's got a parsing framework to extract text and metadata from URLs. It's got an indexing framework or relevancy framework and things like that. A URL filtering framework to decide whether to go after one or not. And there are many places, I've circled 3 here, in which being able to detect the content type is something that's really important, or the file type. Let's take the URL filter as an example. If we're building a vertical search engine, and I heard a number of you guys, some of you here are building startups, or you have startups, and you're basically building what we would call a vertical search engine, one that doesn't care about the whole internet, right, broad, horizontal, but it's in a specific domain. In my class at USC, I call this like, I'm building Yelp, or I'm building Netflix search, or I'm building domain search. Well, you might only want to go after a particular type of content, right? So you might, if I'm building a vertical news site, I might only want to go after RSS files, right? Or I might really simple syndication or news feeds and things like that, and ignore everything else. If I'm building a site that's going to build a digital library of PDFs and something, I want to go after all the PDFs, ignore everything else, and things like that. So in URL filtering, knowing the content type from a search engine is really important. In parsing, it's really important. We wouldn't want to call the text parser on an image file, right? We want to know it's an image. We need to call an image parser on it and extract information that way. The same is for indexing. Certain metadata comes out of certain file types, and we index that metadata in search engines, and we need to know what file types are, so we know like, oh, it's a Word file. It's got a number of pages metadata field, not it's got an image height and things like that. That doesn't make sense for a Word file and things like that. So knowing the content type tells us how we can index information and what metadata is available. So these are just 3 examples. There's many more. So this MIME registry is really interesting. It's really hard to find a diagram out there. In my book, in the Tika in Action book, we drew one basically by reverse engineering it. Me and Yuka Ziding, who's a Finn who lives here in the US now, we actually reverse engineered a diagram of this by reading the RFCs and things like that. But it's really hard to find like a diagram. This is the only one I found on the interwebs about like the MIME registry. And it's actually only showing 7 of the top level types. They added an 8th one later. But these are things like audio, image, multi-part, message, video. These are kind of like top level types, right, for specifying things. So remember how I told you that MIME registry says there's about 1,200 file types that are out there, and it says a lot of information about how to detect those types and what to do with them? Well, that's really useful information to exploit and use in particular ways. Like the magic characters are really useful. The only problem with digital file signatures, though, is we've got to potentially read the whole file, or we've got to have the whole file to get them, right, for reader libraries. So it's useful, but it's computationally expensive sometimes or whatever to do that. So a lot of people will just look at the extensions. We call these glob patterns and things like that, which is just looking at the extensions on the file names to try and determine what types they are. But those have the problem that they're not always accurate, right, or reliable. I can make a .cris file that's really just a text file, right, and things like that. The URL is useful sometimes, whether it's available via a particular protocol. HTTP versus FTP might indicate something about the type, and so on and so forth. And what we typically use, and what we have in Tika, is a detector interface that leverages different detectors that exploit different elements of this, and we typically combine them, either probabilistically. I have a student who has a patch on GitHub right now who built a probabilistic sort of combination detector that combines these in various ways. The default method in Tika is to rely heavily on the MIME magic, and if that sort of is unreliable, to fall back to the other things and things like that to detect them with high accuracy and to detect them with sort of high veracity and things like that. So on the area of like dealing with applications and so forth, one of the things we exploited when we were designing and thinking about Tika was that if we're going to extract text and metadata and language out of files, like how are we going to do that? Well, one thing that you think about if you're thinking about different file types is that file types typically come with applications to read and write them. Right? If there's a new file type, almost always, you don't just invent new file types without having ways to read and write them, and get information out. And so if you think about it, all we're doing in Tika is really exploiting that notion. We're exploiting the notion that there's third-party parsing libraries and so forth out there that we can go and pull in as much as possible, right, to be able to extract text, metadata, and things like that. The trick with these third-party parsing libraries, though, some are better than others. Some fail consistently on certain platforms. Some only extract a portion of text and things. Like some, the metadata is wonky, and things like that. So we've done all the work in Tika for you. And if you don't like it, you can make it better, because it's open source. But we've done all the work for you to decide how to take all of the parsing libraries for those 1,200 plus file formats that are pretty much what exists out there on the internet, and new ones that are constantly being added, we keep track of. We have a number of funding sources and projects that are tracking which new file types are being added that have readers and writers that fill these sort of capacity, and we're adding them to Tika. So if you have a file type, there's a very high probability there's a parser in Tika for it already, right, by exploiting that. So we did all the work for you to figure out, like, okay, we should use this library on, Word, 97 files, and this one on, 2000. We should use this image parser for JPEG, and then fall back to Tesseract if it's, an OCR, and things like that, right? So that's sort of the work that we're doing in the parsing library capacity. The other thing with Tika is that when it parses content, the goal is to throw any file at it, and internally what it does is it parses that file into an XHTML structure. The extensible XML-based HTML markup language, which is HTML with a schema, basically. We did that because it's well-formed and things like that. We also did that, and it's like, oh, XML, we hate that. We're JSON and Ruby people and Python. I don't know. I like Python, too. But in fact, I'll show you how to use Tika from Python today. But yeah, so XML, XHTML, the reason that we did that is because it's computationally efficient to parse it using the simple API for XML processing, or SAX. We can load only the information or tag or characters or things at a time to get things out of that internal SAX structure that we parse everything into, any document internally in Tika, and we hide from you, from the library that we're doing that. And then we can just leverage content handlers. You want all the text? We just strip all the text and don't load any other tags. So it has low computational and memory footprint because we're only loading little bits of that internal structure at the time. It's a standard structure. I don't care if it's an image, it's a Word document, it's a whatever. We map it to XHTML, and then downstream we can chain together content handlers to get things out of it, to get text and metadata and language and stuff out of it. And I'll tell you a little bit about how we do that. Metadata is really important. What you find is that not only are there parsing libraries that are associated with file types and things like that, but typically those parsing libraries extract certain types of metadata. Lo and behold, it's because there are metadata models that traditionally go with file types. Dublin Core is the standard for all electronic resources. It's a set of 15 to 17 metadata elements that are supposedly going to describe anything. It's like author, title, blah, blah, blah. It is fairly general. But more interesting is when you have types like the Office formats and things like that. Did you know there's a standard set of metadata for Office formats? Slide number, date modified, date created, page number, number of words, things like that. They're consistent across all Office formats and things like that, whether it's PowerPoint or Word or Excel and things like that. Adobe has a standard called XMP for all of their Adobe files and things like that, which is a metadata standard that says, here's the things that you can get out of it. EXIF for images, and I'll talk about that today. If you take an image nowadays, it's got a lot of metadata in it that's defined by this thing called EXIF, right? A lot of your camera phones and stuff like that may have things turned off to show things like location, but it doesn't have other things turned off. For example, like camera model number and things like that, camera type, right? Whether or not the camera flashed when you took a picture or not. Lots of useful information in there that's defined by things like EXIF. So there's lots of standards and models out there. And just like I told you for parsing, where we've figured out a lot of that for you, like what the important stuff, how to plug these parsers in together, and stuff like that. We've done the same with metadata. Okay, we try as best as we can to get the right metadata out, get the things that are most consistent. So when you throw a file at Tika and things like that, you're getting the right metadata out. Language identification and translation. So you can't extract text if you don't know what language it's written in. This is my poor attempt from my 572 class, my search engines class at USC, to say I love the 572 class in French. I learned French. Not too useful in Southern California, at least. If there's a French club I can join, great. I probably should have learned something else. Anyways, I use this as an opportunity to show you two elements of text, one in French, one in English. Metadata can also be written in different languages and things like that. And so what Tika has is the capacity to be able to detect language in text too, to be able to say, this is French, this is English, and things like that. And then because of that, we can target how to get information out. So if you have a lot of documents that are written in different languages, that might not be the case for everybody, but if you're dealing with broad scale web or science or even things like that, this is a way to kind of pull that information in and to figure out, to do language detection. And so Tika uses an n-gram approach to do that. N-gram is sort of a splitting technique, a sort of text summarization information retrieval technique to take snippets of, or to take large corpuses of text and reduce it down into sort of snippet fingerprints. Like every three sets of words is a 3-gram, right? All of the sets of that in text. And as it turns out, we can build profiles from those n-grams for different languages, and we've built them already, or people have contributed in Tika so that we can use it to basically compare it to snippets of text that we see and detect whether or not it's that language. It's not super, the accuracy on it is sort of questionable, and we're trying to improve it, but it's computationally efficient, works fast, and gets you a decent result. Just checking if there's any questions so far. I don't hear any. Okay, so Tika is a library that sort of combines all of that stuff that we have to deal with content detection and analysis that supports all that, right? So Tika is a Java. It's written in Java. It's a Java API and a library. We expose it from the command line. A lot of people use Tika using the Tika app, which is command line utility for it. Some people use the GUI. It's kind of crappy. It's just a swing app or whatever. I don't use it. But we left it in there. We wrote it at one point. There hasn't been a ton of improvements to it. A lot of people use the command line, the Java API, and things like that. We recently added a translation API to it. If we can detect the language, we can plug it into translate services, and we've been doing that, or build our own machine translation models, which I'll talk about. Tika also has a REST server, so basically, which has allowed us to expose it to a number of different other languages. There are bindings in Node.js. If you're a Node user, there's a Node Tika. There's a Python Tika. I've been working on that, and also some folks from Aptivate worked on a Python port of Tika. There's one in PHP. Someone wrote a PHP library. There's a .NET library. It's been ported to many, many different programming languages and things like that. I told you a little bit about the history, so I'm not going to kind of go too much through this. But like I said, the original idea for Tika came from myself and a guy named Jerome Sharon. And Jerome isn't too active anymore in Nutch, but he recently became an Apache member. I was really happy for him. He's fantastic. He's the CTO at a web company in France. So we saw, Tika, it's great. We want it to be our own project. Doug and the rest of the Hadoop people shouldn't only, get Hadoop as their own project. We wanted our own. We came to Lucene. I was a PMC member on the Lucene project, which is the search engine that underlies things like Elasticsearch and things like that. And if you've ever used Drupal or Alfresco or Plone, if you've ever gone to the whitehouse.gov and searched, if you've searched in Jira, you've used Lucene, and in turn you've used Tika and things like that. So, anyways, we proposed it to the Lucene people in 2006, and they're like, this is interesting, we don't care. And so we're like, okay, all right. So it didn't get much traction then, and so we waited a year, and then Jukka, the Finnish gentleman who's amazing, was working on a project called Jackrabbit at the time, which is content management system at Apache. And he worked at a company called Day Software, which was eventually acquired by Adobe. And now Jukka works for Google. But anyway, and he's here in the US. But he saw Tika and he's like, hey, in content management, we need all of these capabilities. I'm interested in this too. And he knew a lot more about Apache than we did, or me and Jerome did. And by that time, Jerome had kind of got sucked up into his CTO stuff in France, and it was really just me. And so Jukka taught me how to do stuff in Apache, and helped me gain a lot of understanding of how the foundation worked and what the Apache incubator was and how to start a new project and stuff like that. And so we hit the ground running. We made a ton of releases in the incubator. Got a lot of help, got a lot of interest. Tika became a Lucene sub-project in 2008, and it graduated to a top-level project at Apache in 2010. And we've had a lot of releases since then. We just pushed 1.8. We're working on 1.9 right now. And Tika has very widespread deployment. Why do you care about images and video, and why is this important to you? How many of you guys have heard, or gals have also heard about the dark web? Anyone interested in the dark web? Yeah, so there's an article in Popular Science recently about this. So we've been using Tika a lot in the context of dark web things. So dark web is the web behind forms, the web behind Ajax and JavaScript, the web behind heterogeneous content types. Okay, so DARPA and the government and things like that are interested in it because people do bad things traditionally behind that. So like human trafficking, arms trafficking, things like that, people are sort of doing behind sort of the dark web. if you think about it in science and in a lot of other places, the web is just becoming the dark web. You know, like there was this other article that came out recently. It was so there was a 60 Minutes. I have some stuff. There was a 60 Minutes thing on this MEMX project that we're working on from DARPA, and then there was a lot of articles like in Scientific American about that and whatever. Basically said that most of the web today is the dark web. You know, like the amount of web that we can publicly reach, you know, and things like that that doesn't involve AJAX and JavaScript and heterogeneous content types and forms and things like that is actually very small, right? Compared to the amount of the web that actually normally people don't attack and don't go after and things like that. And so 2 particular projects, just to give you some motivation, are going after that, and I'm involved with it, and Tika is sort of at their core, all right? It's a good illustration of that. So this DARPA project called MEMX, and then I have some funding from the National Science Foundation in polar science, for example, which just shows you that it's not only military stuff and things like that. And I'm not cleared or anything, so I don't work on secret stuff, why I can talk about it, you know, here. So MEMX is 17 performers. There was a thing that recently came out in Forbes that said, like, you know, it's the Google killer. I don't know about that, but that's just, you know, people trying to sort of build buzz about it and things like that. What it is it's a set of 17 different companies and performers, and what we're doing is we're working on capacity in various open source technologies and things like that to make them more suitable to the dark web. So this means like improving things like Nutch for us on our team, and Solar and Elasticsearch and Tika, to be able to extract more different content types that we haven't supported yet and things like that, like images and video and things like that, because a lot of content is out there that was previously inaccessible to us. To be able to make Nutch and things like that crawl behind forums, crawl behind AJAX and JavaScript and things like that, and then to do analytics and analysis. And so our particular team is working with a small business called Kitware, and then another called Continuum Analytics. How many of you guys have used Anaconda? Yeah, so they're the people who make Anaconda, or Blaze, or Numerical Python. If you use them, Continuum makes all of that stuff. Okay, and so what we're working on is a way to make crawling interactive with Python and from Python, and then to extract more content types with Kitware and JPL, and then to expose it via sort of analytics and interfaces and things like that to allow people to sort of do this interactively. So the guy there on the 60 Minutes thing that recently was there is Chris White, who is the former program manager. He just left for Microsoft Research and things like that. And so we've been going for almost a year on MEMX. These are just some useful links to you. I'm not going to go through it, but when I give Felix the slides, there's some references. You can go watch the 60 Minutes thing. It's pretty cool on MEMX. I also am funded via the Polar Cyber Infrastructure program at the NSF, and they have the dark web, you know, too, in polar sciences and things like that. They have a lot of science archives. It's not just polar sciences. We have this in physical oceanography, biomedical, various, you know, things like this. They have archives out there in which most of the web forms and things like that return search results for data using AJAX and JavaScript. And most crawlers don't see that information. They can't get it. And so we're augmenting things like Nutch to be able to like go, oh, this is AJAX, you know, like, it's just a big JavaScript file. Crawler, you become a web browser. And then see this like the web browser would see it. Get the content, parse that, and then use that to go after like links and stuff like that.
Can I ask a question?
Yeah.
So when you try to evaluate the JavaScript in the web, it might exploit your system. How did you avoid that? Fantastic.
Yeah, so I don't. I use libraries in which tens of hundreds of people are working on those problems and they solve it for me. So 2 in particular to point you at, Selenium, which is a web testing kit. And so what we're doing is we're augmenting Nutch to use Selenium as a protocol, and we already have that. And so Selenium, you can define ways to make it so that it runs within sort of a safe environment or something like that so that those potential exploits might not hurt you and things. And then the other is something built by Scraping Hub. It's called Splash. So Splash is a plugin that will interpret a page, generate an image from it, or generate like the HTML like the browser would see it, and things like that. And so Splash and Selenium are the ways that we're looking at doing that.
How about like autoplay video or those kind of more interactive stuff in the web?
Yeah, so part of that involves training these crawlers and things like that on the types of domain-specific stuff that you're going after. And so like in Selenium, as an example, you can create sort of test plays and things like that, which are just like click, point, and like browse interactions over the web, and then save that, and then that becomes a way that you can crawl and replay sort of the way to get content, you know, when you're doing that. Yeah. So The other things that we've been supporting on this is a lot of geospatial stuff. So there's a lot of geospatial data out there on the web in which things aren't tagged with geospatial information. However, we can do things like natural language processing or named entity recognition to like look at text and say, there are places in here. Or look at text and see, there are things in here that we want to extract geographically. And so there's been a lot of work that's been funded on that to add geographic parsers and things like that to Tika so that it's smart when it's doing those types of parsings and things like that, and it can understand geospatial. Image and video. There's also a lot of image and video in the science domain as well to get content out of there. So here's some specific improvements, and I'm going to try and demonstrate this. So I'll just put the microphone down here in a second and try and do some typing. So Tika doesn't natively sort of handle images and videos. So like I said, these are important when you're crawling the web. So in the dark web and things like that. And so two particular areas that we've been adding to Tika to do this is like optical character recognition. How many of you are familiar with Tesseract? So Tesseract is a library that will do OCR from text. And there are other libraries out there that are doing it. Tesseract's just a good example. It's open source. IBM and Google actually recently over the last decade has contributed a lot to open sourcing it and making it easy to use with language packs and stuff like that. So we've been working a lot to add OCR support to Tika so they can handle text from images. So why is that important in some of the dark web areas or whatever? Well, sometimes you have victims and things like that that rather than there being text in an ad, they might be holding up a sign that has like a contact or an alias or a name and things like that. And so it's easy to identify this stuff by hand, but then what if I told you that the size of the dark web, and this is present on the 60 Minutes show or whatever, like say human trafficking, the size of the dark web is 60+ million ads and 40+ million images, right? So you're not going to by hand do all that text analysis, so OCR at scale through something like Tika is really useful there. The other is EXIF metadata extraction. Okay, when you take, so classic computer vision is very expensive. So to run it on images and things like that, we need to train big computer vision algorithms and things like that to detect scenes and people and things like that. What's not too expensive is metadata-based similarity approaches and analysis. And I'll talk about a couple of those. Using the feature space that we can extract from metadata, from things like images, to develop relationships between them. And so I'll talk a little bit about that, EXIF metadata extraction, and how we can use the metadata for images to relate them. And of course, geospatial parsing and stuff like that. So the combination of these three things are three specific improvements we've been making recently for Tika to handle images, videos, and things like that in this particular type of content on the dark web. So a lot of the, so I talked about that, right? Okay, I talked about those things. So Tesseract is a project that helps us do this. I was sort of hip to Tesseract. There was an issue that appeared in Tika 93 in Jira. And so the original person that worked on this was from LucidWorks. His name was Grant Ingersoll, and then a guy who worked at JPL. He was a student in NYU, master's student in data science. Tyler Palsalich took this patch the rest of the way and integrated Tesseract into Tika to be able to extract text from images. So here's how simple it is. So Tesseract on a Mac, and there's also apt-get things and stuff on Linux. You can install it in one command. You know, I'm a big brew fan on Mac and things. Brew install Tesseract, all languages, you're done. And you have Tesseract, and then if you have Tika, you just run Tika, you say, give me the text on an image file, and that's it. And it will natively pick up the Tesseract is installed, it's on your path, and it'll pull the text out of the images. You can also do it from a REST server, so we basically built a way to expose Tesseract via REST from Tika, and things like that. We can stand up a REST service, a web service, which Tika comes with the REST server. Like I said, if Tesseract is installed, you suddenly have something that you can access from any host or whatever that you expose that you can post images to and get the text back from anywhere. It's basically that simple. So I'll try it out. Okay, so what I've been doing in the background, let's see if it actually finished. Oh, I think it did. Is that I ran this command. This is in my home pictures directory for file in JPEG. Do tika-tf and then pipe it to out.log and just keep appending and done. And you can see, well, you can see the quality of this. Like some of it is great. This is my Patriot box that I bought, my home recorder thing. It's great. It's probably from, but then some of it's like, oh, what's this, of some California, so it's not, it's, the things that, so depending on a text, Heyday Films, Harry Potter fans out there, and so I have various things, here. This is all the text from my pictures, and I have a ton of pictures. I got like 10 years of pictures and stuff like this. So, and you can see like some of it's good and some of it's not that great. So, oh, there's a taxi or a taxi fare. So anyways, yeah, like this is, so the cool part about this is that in a search perspective, a lot of times what we're doing is tokenization and we're looking for keywords anyways. So even if, I mean, you can train Tesseract to be better. Like you can train it on particular types of files and languages and things like that to like improve the accuracy. I found Tesseract out of the box is pretty darn good. You know, even if it like jumbles a bunch or 50% or more of the text. Because if you just have some keywords that comes out that you can search for, most of the time in a search engine, you're just doing tokenization and looking for a few of those keywords. So unless one of the key things you're looking for got jumbled, you basically have a way to build quickly an image cat, which I'll talk about later, like an image catalog, you know, of that OCR metadata. Okay, so let me talk to you a little bit about the image metadata and why that's important. Okay, so here's an example of the type of metadata that you can get from images. You can get the camera settings, the scene capture type, the white balance mode, the f-stop. Any budding photographers out there that know what f-stop is? Yes, good, you know something about photography, you're shooting manual, you know, and things like that. My wife's a photographer. This is a lot of information. The exposure mode, you know, the interoperability, thumbnail compression, image height and width, and things like this. This is a lot of information that can be used to identify relationships between images. Who took them? How? When? What was the scenery? Lots of stuff that normally computer vision techniques are keyed up to select. Background, scenery, lighting, and things like that. I'm basically telling you don't need to run a big computer vision algorithm on this. You can get it from the metadata. Okay? Get this information from the metadata. This can be a feature space that you can use to sort of relate images. So first, a little bit of background. Did you have a question, Felix? Or?
No.
Yeah, okay. First, a little bit of background on similarity, right? So we have to talk about web duplicates first, all right? So we'll build up to similarity by talking about web duplicates. So a little bit about the background of web duplicates. It's really important to be able to detect when this situation happens, right? When you have espn.go.com and www.espn.com, but they point to the same content, different URLs. This is one of the definitions of a web duplicate. Different URLs, same content, right? Why is this? You have things like virtual hosts. You have things, you know, some people want, you know, they think espn.go.com is better. It's branding, it's naming, things like that. So this is one way. Another type of web duplicate is when you have two slightly different pages. We're at an ad place. What's the difference between these things? Ads. Okay, great, awesome. So these pages are actually identical. They're two snapshots of the New York Times taken seconds apart with different ads. But they're not identical using the traditional way that we detect web duplicates using this, which is signature-based approaches or hashing techniques, right? We can tell that these are the same because we'll hash both contents and bytes of the page and they'll come out to the same string using something like MD5 or whatever. That won't happen here. And so we need better ways to detect duplicates and things like that. And these types, feature-oriented or near duplicates, right? So two ways to solve it, typically exact match or near duplicates. Exact match, we typically use SHA-1 or MD5 or a hashing algorithm. Those are great if it's exact and things, and we do a lot of that at scale on the web. Near duplicates, we need feature similarity, right? We need some way to featurize content and things like that. And then we need a way to compare the features to detect whether, you know, how much they overlap within some threshold. Okay? And there are various ways to do that, to identify similar documents. So one way is just to compare them character by character, right? That sucks. It's too hard. It takes a long time. We might hash just the first few characters or at some interval of buckets, you know, every offset and things like that to try and develop a fingerprint. That's not great. Or whatever. A better approach is to do some sort of fixed random positions on the document. This is all text-oriented, though, right? Like, this is a way to take text and to featurize it, you know, and things like that. We'll get back to that. We don't have to use text. My point to you is we can use metadata. And we can use the types of metadata that we get from Tika to come out with the features. The general paradigm, though, is that we're talking about similarity. And the paradigm is something like this. It's a function on a document that comes up with a score. Right? So that's the first thing in that tuple right there. We create a pair of scores mapped to document IDs. And guess what? Then if we sort them by score, we'll find all the documents that are similar within a threshold, that all have a very similar score, right? And so generalizing this even more, we're really talking about distance measures, right? How do we measure the distance between content and different types of documents that have features and things like that? Generally, distance measures have to fulfill these sort of 4 properties. No negative distances. The distance between x and y is 0 if they're the same. the distance between x and y and x is the same, symmetry, and then it's got to fulfill something called the triangle inequality. And there's lots of things, lots of algorithms and things out there that fulfill this. There's the Euclidean distance, Jacker distance, cosine distance, edit distance, Hamming distance. I picked the Jacker distance. It's simple. It's a similarity measure, okay? It computes two things: the resemblance of A and B, defined by their feature set, and the intersection of their features, divided by sort of the overall number of features that they have, or the containment of them. How much of A is, or how much of B is present in A, right? That works between two documents. The other one you can do across the whole document set, right? You can do resemblance across the whole document set and basically turn that into a cluster, right? So I built a library on top of Tika. This is at GitHub. It uses Python. It's called Tika Image Similarity. And what it does is for each file or image in a directory, it runs Tika, extracts the EXIF metadata, uses them as features, adds them all to a golden feature set, does another loop for that, and then computes the distance of each document and its features to that golden feature set, and so forth. And we can use that within a threshold to compute a cluster.
But Jacar distance is basically like a bit string of different kind of features, like either yes or no for different kind of categories. And since EXIF is more like a numerical features, how do you do the conversion from numerical to your Jacar distance?
Yeah, so Jacquard, the thing with Jacquard is that you can take the size of the set, the number of overlapping features. So you can compute like the amount of similar names that intersect. So you can either do name-based, value-based, or name-value. So one thing you can do is, do all of these documents have these camera properties? Names. Do they just have the feature names? That's one way. Another thing is, do they have the same values? And if they're discrete values, that's fine. If they're numerical, you've got to deal with that.
Yeah.
And then you can do they have the same name and value, right? And so what I'm going to talk about here is a simple case that just says, are they stamped with the same property names? Which will tell you a lot. Yeah. Good question. So there's a library out there that will do it. And basically the result of this image similarity library are cluster dendrograms. How many of you know what D3 is? Data-driven documents, yes. So we're working with them. Jeff here and Mike Bostock invented that library. And they're working with us on our DARPA project and things like that. They're one of the 17 performers, and they're also working on this project called XData. And so what this is these are image clusters that come out of this image similarity algorithm. So that's what you see on the left. This is sort of a dendrogram, or flare dendrogram, that shows you the clusters. The other thing is that what metadata features make up those clusters? And that's called the circle packing diagram on the right. This cluster is stamped with these properties, and this is why it's a cluster, right? And what's really interesting is that the properties that these images are stamped with tells us a lot, right, about their relationship with each other. Who took them, what scene they're in, what the software they edited them on was, and things like that. We can develop all sorts of interesting relationships just from the metadata. Right, so data viz. So Mike Bostock, Jeff here, Vadim, they were at the Stanford InfoLab and did D3. And so they're working with us. Jeff's at University of Washington now and some other places, and is working on that. D3 is data-driven documents. Basically, the best way I can describe D3 is it basically builds SVGs, or scalable vector graphics, and ties it to DOM, the document object model, in JavaScript. What you do to that document and the data behind it appears in D3 and vice versa, right? It's a technique and a JavaScript library to do that, to manipulate the DOM, bind the SVG and the DOM and the data basically to one another. Okay. So I typically give my students in my search engines class like D3 as like go implement 10 of these gallery visualizations. And these gallery visualizations are great, where I'm linking here on the wiki. You can go to the wiki, get the HTML code, look at what the JSON that you're supposed to generate to use D3 is, and reverse engineer it from that. As long as you can spit out that JSON, which is all I'm doing in Tika image similarity, and things like that, you can use D3, basically. So this is technically where I was going to give the demo. I did it early, so whatever. Yeah, so it's a combination dendrogram and flare dendrogram to see the clusters, and circle packing basically say what metadata features distinguish each cluster, right? And the dynamic version allows for sort of interaction on that. Another thing that we're doing with this is we're tying it into Nutch, the web crawler. We're using D3 and these metadata feature similarities to do things like display the web graph as we're crawling and the similar pages to one another, so you can actually see while we're crawling like what's similar and things like that in each round as we're crawling for it. We're using the REST API that my students are adding to Nutch to do that, and have already added. Yeah, and the power of this approach is that it doesn't require computer vision. Okay. We also then built a product that after the Forbes article, I got like 30 extra likes. Yay, go Forbes. It's called ImageCat on GitHub. Actually, on GitHub, it's not called likes, right? It's called stars. Yeah, I forget. Anyways, I'm just learning this GitHub thing. So ImageCat. So ImageCat, what it is it's basically something that allows you to take that. It's what I built to handle that 40 million image use case or whatever, to do all of the OCR extraction at scale and all of the EXIF extraction at scale. To basically run Tika over all of those things and then dump it into Solr or Elasticsearch. Okay, and ImageCat will let you do that. And that is a really interesting search catalog and index. Some possible things that people have been building on top of that is we built a product that's also open source. And I hate when people say open source and they don't tell you the license. This is all Apache license version 2. And things like that. And then open source in the sense that, I'm just doing an Apache model. If you have pull requests, you can earn merit. You can become a contributor and things like that. Basically some apps that we're building on top of ImageCat is there's something called Image Space and Image Space Experiments. And what this is it's a web front end to ImageCat. To be able to search all the EXIF metadata, to search all, and to do those similarity relationships, to search all the OCR at scale with Tika and things like that. You can imagine this being sort of a very fancy iPhoto that doesn't crash. And we all know iPhotos crash, so that's why you're all laughing. Mine crashes. So anyways, it's there, and you can try it and use it, and people are. It's a big MapReduce project. It uses a software called Apache ODT, which some of you are here, to do ETL, and to basically ETL, get all those image sets sort of MapReduce, divided into partition lists of size 50,000, and then shove those 50,000 images into Solr using Tika and do all the metadata extraction, all similarity in the OCR and things like that. It's on GitHub. Image Space, again, is the app on top of it, and you can see some really cool relationships, like you can do image height and width, basically bubble density diagrams or whatever, and look at really interesting relationships between it. You can do the Jaccard similarity. You can do things like camera model properties, search on them, search all the images in which it flashed or it didn't, and things like that. Any of that EXIF metadata you can search on and you can explore for that. And it's also on GitHub and stuff like that. It's also powered effectively by Tika. So I have various projects. So now shifting gears a little bit, but back to the Polar stuff. So I've also been sort of crowdsourcing through some of my students at USC directed research projects, improvements that use Tika and do things like that related to the Polar deep web and things. I had 3 projects in the fall semester last year. One of them was basically to basically build what eventually became Nutch Selenium, which is to crawl behind Ajax and JavaScript and forms and things like that using Selenium and Nutch. Another was to build a MIME detection that probabilistically, or to build the algorithm, not the code, to come up with the idea to probabilistically combine the different sources of MIME detection information into sort of a more accurate MIME detector. So my student worked on the algorithm for that. And then we also built something for gridded binary image parsing, or GRIB parsing, GRIB files, which are used in the scientific domain and in other places. And we built a parser for that in Tika, which was code. This past semester, my students have been working on the REST API. So if you download Nutch, it has a REST API now in 1x trunk, and that was basically built by my students to enable some of these data visualizations and things like that. We built geotopic parsers, so that the NLP way of geotagging things or whatever, that came out of the work from my students. Other support for geospatial data, ISO 19115 files, GCMD diffs, and directory interchange formats. Someone actually implemented the Bayesian algorithm that someone came with last semester, and it's now on 2 pull requests in Tika for that. We've been combining Spark and Tika to run it at scale and do sort of content detection and analysis at scale, like an ImageCat thing, but using Spark. How many of you know what the text retrieval conference is, or TREC? Yeah, so there's a TREC dynamic domain track this year. So the dynamic domain is the dark web, basically, and all of those things. And so we used all of these improvements, all of the work we've been doing on Tika or whatever, to generate 2 data sets for the dynamic domain track. So if you want to participate in TREC this year, TREC is the text retrieval conference from the National Institutes of Standards and Technology, or NIST. And so TREC solicits people to work on data sets in various tracks and then to contribute papers and stuff based on their working on those data sets. So we contributed a big polar data set from all the work we've been doing on the dark web and stuff for polar. And we also had a MEMX contribution of a data set related to Ebola. So we collected a bunch of Ebola information and stuff and put those up. So all those data sets were contributing, got by all the work that we've been doing. So it's a cop-out. I said there would be videos in here too. Tika has some issues with FFmpeg right now. Do you guys know what FFmpeg is? So it's a great tool that you can use to actually extract information, and it's in the vein of Tika. We're not writing video parsers. We're trying to integrate what most people use. So FFmpeg is a tool you can actually call from the command line. It's an editing tool too. You can do a lot of things, but you can also extract information from videos. It's broke in Tika right now. There's the issue if you want to fix it. I'm trying to fix it. We'll see if I get time. Headed to Hawaii on Friday, so I don't know about that. But there's also people that are working on videos, and one of our goals is to build VideoCat. So there's some information there related to it, and we were also trying to figure out streaming videos in Tika. Other applications of Tika, and I'll give you one more example right now. I'll tell you about how to use it with machine translation real quick. But we're also using it for bioinformatics. There's some people that do bioinformatics here and things. You're familiar with Isotab as a format? It's a very standard format or whatever. I've recently become familiar to it. I didn't know anything about it before, but there's an Isotab parser in Tika now for bioinformatics. CTAKES is a clinical NLP and named entity recognition toolkit, and we're integrating that into Tika too. There's a Tika Python library, and it was originally built using something called JCC. Do you know what JCC is? So yeah, most people don't. It was part of, it's the way the Lucene project builds PyLucene. It's a way to compile Java code into C++ libraries that you can bind to Python. The problem is it's not very portable at all. And so I had to write this horrible, let me just show you the Tika Python install guide so you can laugh. If this, then that, then, if that doesn't work, no, really, try this, it's a pretty ugly guide. I mean, it's not too ugly, but it's ugly enough, and it's all because of JCC in the default branch. And so anyways, the answer to that is that we have a REST server in Tika, and so I actually have a branch in Tika. Oh, why did I go back to this? I wanted to show you a demo. Let me show you a demo of it. We have a branch. Not OpenOffice. Go away. Yeah, go away, OpenOffice. Yeah. So there's so this is our new. This is in my Tika REST branch on GitHub, and so this is the new Tika Python that we're working on that just binds to the REST library. Zero install. It'll install it for you. It's not ugly JCC everywhere and da-da-da. And this is it, just calling Tika from Python using the REST library underneath it. So it starts up a REST server unbeknownst to you on a particular port. It starts and stops it, takes care of it, it hides it in temp, so you don't have to worry about it. And it's actually just a lightweight Python library around all that stuff. So that's the better way to do it. And if you want to help me make it better, great. I've got 2 students and then someone else working on it right now. And then there's also something called ETLlib, which is an ETL library that uses Tika to go to JSON and other things that we can then load JSON documents. Anyways, I told you I was going to talk about machine translation. I'll talk about it real quick. Another DARPA thing that we had was this employment data. It was collected. It was 192 million jobs collected in Latin American countries. It's the equivalent of Monster.com. It's a site called Computer Bajo, computer work in Spanish. 195 million or 192 million jobs. And what they are 119, I'm sorry, 119. It's about 40 gigabytes of data, all TSV format, so tab separated values, semi-structured. And we were asked a bunch of questions about this because they were trying to look if jobs in a particular area were an indicator of potential unrest and things. And so some of the interesting things, or economic uptick and stuff, does it mean something with respect to people and what's going to happen in that domain? So really interesting challenge questions that came out of it that we felt could be answered by basically taking this data and loading it into something like Solr, using Tika and things like that. The big problem was that the data was all in Spanish and people wanted to query it in English. And the data was all noisy and ugly and all of this stuff. The geolocation was messed up. So it was like an ETL job, and this was the big impetus for us. This happened last summer to basically make Tika support translation. And so there are two, let's see, should I stay on this one or not? Yeah, okay. There are two major ways to do translation and machine translation. One is to use API-based translate toolkits like Bing and Google, Lingo24. They provide you ways to translate text. You give it text, gives you back you give it text, you tell it the source language, you tell it the desk language, it gives you back the translated text. The problem is they all have API limitations, and it took them all a long time to build those tools, these translation toolkits like at Google and Bing and all of these things. And so to do that, that's why they charge you. It's a value add for their business to do that and stuff and to have these limitations. However, they're highly accurate and they have great data and all of this stuff. So we support those types of translations in Tika, but we also support bring your own model or train your own model. And the two open source main toolkits to do that in machine translation are Joshua, which is made by John Hopkins and an open source project on GitHub, and then something called Moses. It's like over 1,000 papers have been published. Like the statistical machine translation community like basically grew up with Moses. Like they published papers using Moses. I thought Joshua was a little easier, and it's also more permissively licensed. It's BSD licensed versus Moses, which is LGPL. Anyways, we basically added a translation layer to Tika. So if we can detect the type of language, which we can translate it too. And there's all sorts of like impact for doing stuff like this. Like if we can translate the text or the metadata and things, if we can detect the language and we can translate it, we can map them all to a common language. We can move them between languages. We can, support search. We can support analytics. We can support lots of things. And so all of the translation stuff in Tika basically came from us working on this. Improvements to the Tika Python library to support translation came from that. The ETL lib thing came from that. And there's lots of stuff that we had to sort of get around that I'd be happy to talk about sort of offline, with that. Some of the things are just dealing with when to use the API versus translations versus dealing with bringing your own model. Bringing your own model to translations is kind of hard. You've got to build it. It takes a long time. It's not necessarily as accurate as the broad models and services from the translation stuff. I'm not going to get into all that. But I just wanted to let you know that translation is also a part of Tika, and that's also something that was originated by some of this DARPA stuff, which is traditional DARPA. It's like innovative and then transitioned into like society. So of course this has to tie back to NASA JPL. So we're doing this with PODAC. They care about the images. It's not just solving all of these dark intel types of things. Polar cyber infrastructure, science images and videos from Mars. And then there's actually a project that's based on that translation stuff in Tika. It's called IPRES, which is translation for our physical oceanography data and data center. That's also on GitHub, and Louis John McGibney, who's on my team, is working on that. Thanks. That's me and my wife. They're expecting me at some point tonight. And my son. Thanks.